So you may notice this is a single replacement form, Ag plus HNO3. That looks single replacement to me, A plus Bx. But I have all the exceptions to the single replacement, all the failures of the single replacement reaction memorized. Do you? Do you know when single replacement fails? Did anybody write those down? I went through those.
That was when the strongest was not the strongest one, so like.
Yeah, and then when does that typically happen? When it typically happens, when things don't play their role, is when, one, you have, did you guys memorize those? If you didn't memorize those, then it's probably the safest thing to do is probably to break it down and use the chart method. That's the safest because if you wrote down this is going to form silver nitrate and hydrogen gas, and then you compare the activities and you go, okay, there's going to be no reaction here. There's NR because this hydrogen is more active. And silver is less active. And so that means there's no reaction, NR. There's no driving force. And so you might think, well, there's no redox reaction then. But that's wrong. There is a redox reaction. That's because this is one of the exceptions you memorize. One of the exceptions that you memorize is that single replacement fails for what type of acids? What type of acids does single replacement fail for? It's spring break, I expect things to be slow after spring break because who wants to study over spring break? Nobody, basically, I think. But once we're back into the swing of things, the recall should be pretty fast for this. What is it?
Strong acid.
It's not strong versus weak. It is this versus that. What is it? So, the easiest thing to do is not even talk about it. That's what the book does. The book doesn't even talk about it. The book doesn't even talk about it because they'll never give you a problem like this. They won't give you a problem like this because it'll fail. It will fail. And so the easiest thing is, just don't give those types of problems. The problem is you can't go that far in science by eliminating all the difficult parts. You have to do the difficult parts too. Later on, I guess you could do them, but this is like this chart, there's a reason why I review this every once in a while so that I can recall things a little easier. Otherwise, if you're approaching this chart like it's the first time you read it, then it's going to be slow. You're just going to be slow, that's all. You want to be a little quicker. Like for this, what type of acids do single replacement fail? You want to be a little faster. Being a little faster, all it means is just looking at it once in a while. Every day, actually review that. Every day. If you look at it every day, then it's easy to memorize the three. But what I found in teaching this is that nobody memorizes it. if nobody memorizes it, then the best thing to do is use the chart method, because the chart method, you don't have to worry about pre-assigned roles. The chart method, you pick the strongest based on the chart, not based on some pattern. You know, single replacement, we base their role on some kind of pattern, and this pattern fails sometimes. In other words, the single replacement is going to tell me what is the oxidizer. At least you probably have that down. What is the oxidizer in single replacement? A, B, or X? X is not. X is called the. What roles is it? A is called the reducer. B is called the. X is called the spectator. But there's a big problem here. The big problem, I already see the big problem here right away. Because X is nitrate. And the oxidizer is, well, according to the roles based on the pattern, B is the oxidizer. What is B? B is H+. X is the spectator. What is X? Nitrate. Well, does that make any sense? Here's H+. Okay, that's an oxidizer. Yeah, that's good. And here's nitrate. Nitrate's a spectator. Does that make sense to you? Because it doesn't make sense to me. Why? Because nitrate is a much more powerful oxidizer than H+. How much more powerful? That much more powerful. Look how much more powerful it is than H+. Do you think that's going to work? Do you think nitrate's going to be happy? Okay, H+ takes the, well, if nitrate is very generous and says, okay, I'm going to skip my meal of electrons, you eat it. But do you think nitrate's going to be so virtuous? No, I mean, these are chemicals. These chemicals, they don't have a mind. They can't be, yes, H+ does want electrons, but if there's going to be a fight between H+ and nitrate, who's going to win? If there's a fight between H+ and nitrate for electrons, who's going to win? Nitrate. So that's why I said, the thing is, you can memorize it, like, okay, these types of acids is always going to fail, or you could have a better understanding. If you have a better understanding, of course it's better. But initially, the first part is just to memorize it, you know, because then you're safer than that, and the better understanding can come later. And so, does anybody even recall when I was talking about acids? There are two types of acids. One type of acid is called the mineral acid. The other type of acid is called the This was in lab. The other type of acid is called the oxidizing acid. Oxidizing acids, they're characterized by having an anion that's a more powerful oxidizer than H+. And so oxidizing acids would be nitric acid, sulfuric acid, iodic acid, etc. There's a whole bunch not on this chart. A whole bunch. You can figure out based on the anion. And so, for me, because I haven't memorized, I know what to look for. I know this is going to fail. Single replacement fails. What else does it fail? What else? Okay. For each failure, I gave an example. So when you get some time, just look at the examples. And probably the best thing to do is, if you want to do single replacement, you memorize the failures. You memorize the failures, and then you're going to be safe. if you don't want to memorize the failures, and at this point I think it's just safer, because memorization is an issue, I would say it's much safer just to use the chart method. The chart method is a little longer, more steps are involved. Single replacement is a lot faster, but there's a danger with that speed. With that speed comes error. And so take the safe way out and just do it. Break it down. What's the first step in chart method? Inventory. So this is a common mistake. No matter what I say, no matter which semester, if I gave this on the test, maybe about 1/3 of the class would do this. That's wrong. So about 1/3 would get it right, and about 1/3 would get it sort of wrong, sort of right. Struggle with it.